So we're going to be in Chapter 2 tonight, working with data, creating modules, and designing high-quality programs. And this particular chapter is really talking about some of the things you've already been looking at, declaring and using variables. But then the new thing it gets into is creating modules, and that's one of the things that we'll be doing a lot through the rest of the semester. And so this just sort of gets you started in that process, and then some of the other chapters further down the road get into more deep depth than what we'll do here. So to start with, we're just going to work through a few of these slides, and then I'll show you some examples as we go. So first of all, variables. Now you've all been using variables and did those on your first assignment. And like we said then, a variable is essentially a box where you can put data into it. And variables, the formal definition is that they're named memory locations. And they have a name and they have a type. So when you're creating a variable, that's one of the things you have to worry about is the name of the variable and its type. Fire up free basic here, and basically, right, you start with dim, and then you give your variable a name, and then its type. It's as simple as that. When you name a variable, you can't put spaces in your variables, and you can't start the variable out with a symbol or a number. And those particular rules are fairly standard across most languages, so basic is no different. That's the rule. So usually what we do is most of our variables are one or more words, and we just put them all together and use the camel case naming, which means you put a lowercase letter for the first word and uppercase letters for all the other words in the variable name. So at any moment in time, a variable holds a single value, right? Which makes sense. In most languages, before a variable can be used, it must be declared. This is what we call a variable declaration. So, comment here. So what they're saying is I can't just go in and type x equals 10. In most languages, if I try to do that, it won't let me. What I have to do is declare it first. Then I can use it. So again, here's another variable declaration right here. And in this class, there's really three types of declarations. You're either going to create a variable that holds text, which would be a string, and you're going to be doing variables that hold numbers with no decimal places, which we call integers, and then you are going to be storing like monetary data, so like a sales amount, and that would be a single. So it really comes down to those three data types. There are others, but those are the main ones that you'll use for most everything that you do. String, integer, and single. And as you can see as I'm naming these, this particular one is just one word, so it's all lowercase. And this one is using that camel case convention. So now, these are declarations here. There's another term that they use called variable initialization, and the first time you set a variable, you're initializing it. So, spell that right? Yeah, I think so. So I'm initializing the variable. So the deal is when a variable is created, its default value is usually 0, or if it's a string, it's got nothing in it. And a lot of times we want to set a variable to something to start with. I'm going to preload it with some value. And that's initialization. Now, you can do the two things together. You can say dim rate as single equals 0.06. So I'm doing both together. I'm declaring and I'm initializing in one step. So if you ever want to create a variable and just set it to something initially, this is really the best way, I think, to do it, is just to do it all with one line of code. So if you're creating a rate or do that. Of course, if it's a constant, like a tax amount or something, you might want to consider doing this. So actually, if you're doing this, the state sales tax, you might want to make it a constant, because it hopefully won't change when you run your code. That's the whole point. You don't want it to change. And of course, when you're doing a constant, one of the conventions that most programmers follow is they put it all in uppercase letters. So something like that would work, or you could do an underscore. It doesn't really matter how you name it. It's just all usually in uppercase letters. So for constants. So if I try to change the tax rate to 0.08, it gives me an error. This particular error, it doesn't want me to change because it's a constant. I can't set it equal to something other than what I set it to when I created it, which is 0.06. So the compiler won't let you change a constant once you set it, which is a good thing. That's what you're after. Here's a problem. If you create a variable, like we have age up here, dim age as integer, and I say age equals age plus 10. In a lot of languages that won't fly. Now if I try to run that here, print age here and put a sleep statement there and run it, it prints out 10. And the reason it does that is because in the basic language, when you create a variable like this, if you don't initialize it, it does it for you. So when you create this age, it's going to initialize it to 0. And so what I'm doing right here is I'm saying age equals itself plus 10. Well, if it started at 0 and I bump it up to 10, or by 10, it becomes 10. That's the new value. So, however, a lot of languages, in fact most, will give you an error if you try to do this. What the error will be is that you're trying to use a variable before you've initialized it. So they would say, look, you've got to set the age first to something before you can alter it. So just something to keep in mind if you ever use a language, that usually what we do is we always declare and initialize variables one step, and then you're covered. Then you don't have to worry about it. So any questions about that so far? So this declaration is a statement that provides a data type and a name for the variable. So again, here's the data type, here's the name. These are all declarations. They're usually placed at the top of your program. So usually when we create a program, we declare all of our variables right at the very top. And then sometimes we'll use comments to describe them. And you can always put comments next to the variables. And so like over here, you probably would want to line them up nicely so they all look aligned straight. And then you could just put up here, what the variable's for. Now, sometimes it's just obvious what it is. Like this one here, it's called username, right? So obviously, to go over here and say user's name is kind of silly because it's pretty obvious. But occasionally you'll have a variable and you're like, well, what is that for? Well, then you can describe it in the comment section over here. You just stick a comment there. It's definitely not necessary. You don't have to do that unless you really need to. So, like in this case, there's really no sense to do that. Age, it's pretty obvious what that is, so I can get rid of that. So it's just kind of it's just based on what you're writing and how clear it is or how not clear, whether you put a comment there. So I've got an example here, which what I did, and by the way, out in Blackboard, I put out for you a PDF file that has something similar to this. It teaches you how to go from pseudocode all the way over to free basic, and it starts with the pseudocode on the left column. So if I was to write, this is the program that multiplies a number by 10. So first I get the number from the user, then I multiply it by 10, and and then I print it to the screen. So if I was to write the steps down in just plain old English, I would write these 3 steps. Well, to turn that into a flowchart, we're doing this. So you got your start symbol, your input box here, your processing, and then your output, and the end symbol. And then over on the right, this is the free basic code that you would build to pull this off. And so I just tried to put it all together for you so you could see the whole picture. And as you can see here, I put my name at the top, and here's where I'm declaring my variables right here. And that's what they're showing in this particular example. That's why this is highlighted, because they're showing you that step. So I'll continue to do these the more we go into the chapters, so that when we cover a particular topic, like we cover loops, or we cover decision making, or any of that kind of stuff, I will go in and put a chart like that together. It just makes life easier for you all. So, and the book doesn't really show free basic. That's the thing. They don't talk about any specific language. They don't commit to a language. They try to keep it neutral, which doesn't help you if you're trying to do free basic. And so watch for those. I'll keep putting those together for you as we need to use new things. So, okay, data types. I already talked about this basically. You either have a string, you have an integer, or a single, and we'll get into that more in a minute. But when we talk about variable names, as I said, you can't begin with a number or a symbol. We use camel case. You can't have spaces. And when you pick a variable name, try to make it meaningful. One of the things that a lot of times people do is they abbreviate variable names. So they'll say HP alien as integer. Well, it's the number of hit points the alien has on it. Let's say you're building a video game or something, and you have to keep track of how many hit points the thing has on it. Just looking at that variable, you wouldn't really know. So, you could either do this. You could say hit points for alien, so you've got a comment to describe it, or rename it to alien hit points. So there's a trade-off here, because your variable names can get really long. If you don't use abbreviations, then you end up with this great big variable name, and you have to type it every time, and that's a real pain in the neck. So it's not like abbreviations are bad. It's just that you try to avoid them unless you really, really need to use them, because they can make your code look kind of cryptic. And so there's no hard set rule for this. It's just, generally speaking, it's better not to use them if you can. So try to be more descriptive in your variable names as opposed to using a lot of abbreviations. So that's when they say variable names should be meaningful. Like if you created a variable like SDJS, okay, probably not the best choice, because you have no clue what that means unless you wrote the program. But if somebody else is looking at this, a month down the road, and you're not around, and they're looking at this SDJS variable, they're going to say, "What the heck is that?" You're better to spell it out for them. So, okay, variable initialization. We've already talked about this, so I think I'm just going to move to the next slide. I put some examples here for you in free basic, and some of this you've already done, but to declare an integer, you just dim something as integer, string, dim something as string. And to initialize, you can set them equal as you see here. Now, numbers, you don't use quotation marks when you initialize the variables, and strings you do. That's the only thing to watch for over in free basic. Let me just switch back over. So if I was creating a variable called username as string, and I wanted to initialize it, that would not work. And in fact, if I tried to compile it, it wouldn't compile. So you have to put the word, oops, quotation marks. On the other hand, if it's a number, you just put the number. You don't want to use quotes for a number. So you'll get another error here. It won't like the 23. So let me take this out. Doesn't like the quotation marks, and so take them out and it's happy. So that's just another thing to keep in mind. Integers don't take quotes nor do singles, but strings do. And they have this in the book. They talk about literal constants. Now, when you take the number 23, they call that a constant, because obviously it's a number. If 23 is 23, you can't change the number itself. It's called a literal constant, or sometimes referred to as an unnamed constant. If I create a constant called tax, that would be a named constant. So actually, this is a constant here, but it's an unnamed or literal constant. This is a named constant. This is a variable because it can change. This is a constant. So usually we would just call this a number, right? But the formal term for that is an unnamed or a literal constant. So when you read that in the book, and they talk about that, that's what they're really saying there. So like even for strings, the string college is a literal string constant. Create a string and you give it a bunch of characters, it's a constant. And in this case, a string constant. So seems pretty obvious, but that's one of the things they talked about in the book. So for named constants, you use the CONST keyword, as we just talked about, and you capitalize the name of the constant, and then you specify its data type just like a variable, and then you can initialize it, so you're declaring it and initializing it in one step. So sales tax would be 0.06. Once you've initialized it, then you can use it in your program. So pretty straightforward. The next thing the book gets into are the arithmetic operations, and it's pretty straightforward. You've got plus and minus. For multiplication, you use an asterisk, and for division, a slash character. Right? So not too big a deal. Here's where you can get into some trouble right here. If you were to ask 10 people what the answer to this was, you'd come up potentially with different answers. So like, for example, what do you all think the answer to that would be?
14.
14? Any other options or ideas?
Operations.
20, yeah. Right, it just depends. So, some people would say, well, it's going to be 20 because you got 2 plus 3, which is 5, and then times 4, you got 20. Other people would say, no, you take 4 times 3 first to get 12, and then add it to 2 to get 14. So you remember the wonderful algebra class that you had, and when I was there, well, actually, I think I learned this back in 7th grade or something, this little lingo here. Has anyone ever learned it this way? Yeah, okay. I don't know where, it seems to stick with you, right? P is for parentheses, E is exponents, and then multiply, divide, add, subtract. So the idea is, as you're going from left to right, you're going to be looking for multiplications first, then divisions, then additions and subtractions. So looking at this, I see that I've got a multiplication, and that takes higher precedence than the addition. So it'll take 4 times 3 to come up with 12, and then 2 plus 12 is 14. So whoever said 14, that is correct. So now sometimes this just gets a little bit of a pain in the neck to try to wade through these things and try to figure out what the numbers are. You can always use parentheses if you aren't sure. So like if I print 2 plus 3 times 4, I mean, it'll come out 14, at least it should. It's coming out 14. But if I were to put parentheses around this part here, it forces it to add 2 plus 3. The parentheses always mean do me first, right? They're the top. If you go back to the slide, it's the very first thing is parentheses. And so when it sees parentheses in there, it immediately jumps into those and does whatever's in those first. So in this case, it would take 2 plus 3 to get 5, and then multiply that by 4 to get 20. So this equals 20, whereas if I just do this, it's going to be 14. So there is a difference in, now if you were to put 2 plus 3 times 4 like that, I mean, it still comes out 14. The parentheses aren't really necessary, but there's nothing wrong with putting them in. In fact, I usually put parentheses into really complicated equations because it just makes them more readable and it's just easier to understand. So I looked at this and said, all right, it's gonna do this first. It's gonna multiply 3 by 4 and then add it to 2. So there's nothing wrong with doing that. You never worry about adding parentheses. It's not really a problem. It's not going to hurt anything. Now you can overdo parentheses. That's just kind of silly, but it still runs. I mean, it still works. You can run it and you get your 14. But obviously, there's no need to put a parenthesis around the 3. But it doesn't hurt either. So I'm just saying you can't really go wrong. The only thing about parentheses you got to watch out for is forgetting, if you do some opening parentheses and you forget to close one. Now in this example, these are kind of silly to have in here, but you'll notice if you click on an open parenthesis, it shows the closing one. If I were to have forgotten a closing parenthesis, when I click on this guy, he's got no matching parenthesis on the other side. And so that tells you that you're missing one. And that's one way to find out, is to click each one to see if there's a match. The other way I do this is I start numbering them. If I see an open parenthesis, I add. So I start at 0. If I have an open parenthesis, I go to a 1. Another one opens, I have a 2, and then a 3. And if I close, I subtract 1. That brings me back down to 2. And I close here, it brings me back down to 1. If I start at 0, I need to end with a 0. And here I'm starting with a 0, and I'm ending with a 1. So that tells me I need one more parenthesis to bring me back down to 0. So if you ever get into a jam and you're not sure where the closing parenthesis goes, that can help too. At least it tells you where you're missing one anyway. It's a technique sometimes that I'll use. So, something to think about if you're using parentheses. So, order of precedence or order of operations. It's in the chapter and you can read about it there. Questions on that stuff? Okay, the big thing in this chapter is modularization, and talk a little bit about that. When you write a program, usually they end up being quite large. I mean, the stuff that we're doing is pretty small, and we may end up with 15, 20 lines of code, but I'm talking about a program of thousands of lines of code, right? And what happens sometimes is that you end up writing code and you repeat some code. So like if I'm just writing lines of code, and let's say that I enter a couple lines, it doesn't really matter what they are, and write those, and then I go about my business doing some more stuff, and I use the same 2 lines of code again, and again over here. Well, there's nothing necessarily wrong with that, but what I have here is duplicate code, right? I'm duplicating my code in these places here, here, and here. I've got the same code. Now, let's just say I needed to make a change to this line of code right here, this point. So I make the change. Now, in order to really make this work, I'd have to change it over here and over here. But the problem is, I might forget, or I might just change it in one spot and forget to do the other places. And so that's one of the issues, that it can lead to errors if you have a lot of duplicate code. And then not only that, but it's just a pain to have to change it 3 times. I mean, you're making the same change 3 times, and it's just kind of pointless, really. You don't have to do that. Because the alternative is to take all 3 of these, put them into what we call a module, right? So I'm going to take those 2 lines of code, put them off to the side, and put them into a module. Now I have to give, this circle represents the module, and I have to give it a name. So you'll see this in programming. They'll use the term foo for a function because they don't know what else to call it. You have to give it some name. Now, so I've got my code sitting down here, and I can call it from anywhere. But then what I do is I come back up here, right, and I take these lines out, and instead I call my module. Now, one of the benefits here is that, so if you need to make a change to something down here, right, you only have to change it 1 time. I don't have to go looking through my code for every place and have to change it a bunch of times, right? So if I just change it once, that's all, well, then I'm done. These lines here, they just call into the module down here, right? So when you're going through code 1 sequence at a time, and you hit this point right here, it's going to come over here, walk through the lines of code over here, and then it's going to come back up to where it came from, and then continue down from there. So it's just going over here, executing these 2 lines of code, coming back up, and then continuing on its way. And so 3 calls, 1 procedure or module. Now, there are different names they assign these things, right? When I use the term module, another name for that is a procedure. It means the same thing. Module is equivalent to a procedure. So sometimes you'll hear me use the term procedure, and yeah, it's the same idea. Well, another benefit of doing this is reusability. I've got this thing separated off on its own. So if somebody else wanted to call it and use it, I could expose that so they could use it. It's not embedded in my program. It's been pulled out over here. So potentially someone else could call it and use it. So if I had a really useful function, so like, you're working at a company and you're building a program, and you write some code down here that's really helpful, it's handy, and maybe some other people want to use it. And so you say, look, I've got this procedure, I'm going to put it in a file, and whoever wants to use it can use it. Then we have something reusable, and that's another benefit. So those are some of the reasons why we do modularization, and there is one other reason: to abstract details out of our code. So for example, if you had, just erase this off a minute here. If you had a bunch of code in here, a really large listing of code, right? Sometimes what we do is we just break it into modules. We break it apart a little bit. And so we would say, okay, we've got a module that does this part, and another module that does this part, that does that part. And say this module is called A, and we've got B, C. And so in our program here, instead of all this code, we would call A, call B, and call C. So our program would, the main program would have 3 lines of code in it. And all they do is call over to the procedures and do all the work over here. This type of a concept that we're talking about here, the book has a term for this, and trying to think of what they're calling it. I thought I put this in my slide. Oh, selective. Okay, so they call it selective ignorance, which what they mean by that is, okay, you look at when it says call A. A might be something like get information from user. Well, you don't really care how it does its job. You just want it to do it. So when I call A, get information from user, it just goes out and does its thing. B might be something like calculate results, and C might be called print output or something. And so all the details are abstracted into these modules over here. It's sort of like if you're trying to describe to somebody the process you go through to get ready to come to school in the morning, right? So you're probably not, if you talk to them, you're going to say, well, okay, I got up and I had breakfast, took a shower, and started the car, or maybe you just say I drove to school, right? So take that one thing, drive to school. What you're not going to say is, well, I found my keys, I opened up the door, I got in, closed the door, put the keys in the ignition, turned the crank, put the car in reverse. You go on for an hour telling them every little detail about what you do to get to school. Well, that would be really fun. Versus just saying, well, I just drove to school, right? They don't care about the details, and all you just have to say, I just drove to school. So you abstract out all the details into here, and then you don't worry about them. So your main program is just, look, I got out of bed, ate breakfast, drove to school, and all the details are over here. That is called abstraction, and that is another reason. Otherwise, this main program would be huge. It would have every little detail in it. And maybe we don't care about all the details. We don't want to know them at that point in time. So those are some of the benefits of breaking up code into modules like this. And so when you look at the slide, then modularization is breaking a program up into units rather than one great big set of instructions. And these modules are referred to as procedures. They're also called methods. So they all mean the same thing: procedure, method, whatever. So let me switch back over to here for a second. So we have module, procedure, method. They all mean the same thing, right? There are 2 different kinds of modules, procedures, or methods. There are subroutines, functions. We really don't need to know too much about this yet. This is going to come more into play when we get into the later chapters. But for now, you think of a procedure, it's going to do something for you, right? You may have to give it some information for it to do its job. So if you think about a subroutine and a function, you have to put things into a subroutine or a function. You have to feed it with data. So for example, if either one of these things were going to calculate some results for you, maybe let's say it was really simple. They had to add 2 numbers. Well, you'd have to feed the 2 numbers into the subroutine. or into the function. The difference is a function will spit out or return a value. Subroutine will not. So when you call a subroutine, you may or may not feed it things. It just does what it's got to do, and it finishes. The function, it always spits back a value for you. So if you think about a box, you turn the crank, out pops the answer. That would be a function. A subroutine, you just tell it to do its job, it goes away and does it, and that's, you never hear from it after that. So there is a distinction between subroutines and functions, and you'll notice in Free Basic, when we're going to be creating modules, starting in this chapter, we're going to start, when we create a module, we're going to be creating a subroutine. We won't be doing functions for a while yet, and that's okay. Just so that you know, that's the difference between the two. If you hear the term function or the term subroutine, there is a difference. Both of them are modules, procedures, or methods. Essentially, they are all in that category. So, but basically then, okay, so a module is called a procedure or a method. A procedure that returns a value is a function, and if it doesn't, it's a subroutine. That's what we're really saying here. So, benefits of modules. Abstraction, which we just talked about. Multiple programmers can work on a problem. That's another benefit. You can say, look, we got 10 people on our team. Each of you go off and write a module, and then at the end of the day, we'll all come back together, and we'll glue them all together and see if they work. And of course, they usually don't. But there's something called an integration phase, right? You let everybody go out and create these variables or these modules, and they all build them independently. When you put them all together, they have to fit, and that is where you can have trouble. You know, so, and I don't know. It seems like you go to the store and you buy something that you have to assemble. And you've all been there. Instructions are either really, really bad, or the parts just don't seem to fit together right. And you're following the directions, but the stupid thing doesn't fit together, right? So you get the hammer out, you start pounding things, and then you realize that, oops, I put it on backwards or something. And that's why I'm in programming and not any kind of mechanical stuff. I can do light bulbs and things just fine, but you're pushing it beyond that. But the idea is everything has to fit together, and you know, when it doesn't fit together, it's so frustrating. Well, okay, modules are the same way. You want to make sure they all get glued together right. So somebody's got to make sure they all work together, and that's actually a pretty big task sometimes to do. So, but we'll talk more about that as we go. The modules allow you to reuse your work more easily because they're separate little pieces that you can plug in anywhere, at least in theory. That's the idea. Okay, the structure of a module. These are the pieces of a module. You've got the header, the body, and the end statement. If you look at this right here, this is in Free Basic. This is an example of a subroutine. It starts with the word sub, and then the name of the subroutine, which I called it display welcome. And when you name a subroutine, we use a naming convention called Pascal case. Now, not everybody does this. Some people like to use the camel case convention for subroutines and variables, and so they'll have a lowercase d here. But most everybody I've worked with uses the Pascal convention for modules, which means you capitalize the first letter of each word. So that's basically the idea. Capital D, capital W for display welcome. And usually, when you name a module, you give it a noun and a verb. Right? So display welcome or print report or something like that. This particular one, It's a subroutine. That's why sub is there. Its name is display welcome. And notice the parentheses. This is another thing that has to exist when you create a module. The parentheses there, and there's nothing between them, and that basically means that this subroutine doesn't, you're not giving it anything to do its job. You're not feeding it any inputs. It doesn't need anything to do its job. You just call it. And that makes sense because all it's doing is printing out a message. You shouldn't have to feed it anything to do its job. So this would be the header right here, this first line. The body of the procedure is the code inside. And it's usually more than one line of code, but just to keep things simple, we made it one line. And then the end sub is the end of the module. So that's basically all there is to that. So I have an example which it's not the easiest thing in the world to read here. See that okay? All right. What this does is forget about this line right here. Let's go right to where it says declare variables. We've got a customer name and a balance. Customer name is a string. The balance is a single. We're asking for the customer's name with an input statement. We're asking for the balance with an input statement. And then right here, we're calling the display address info module. That module is over on the right. So on the left side, we're simply saying call display address info. We don't really care how it does it. We just know it's going to do it. That's this whole idea of abstraction. We're just calling it, saying you take care of what you got to do. We're just going to call it, let it do its thing, and when it comes back, we're then going to print out the customer's name and balance. Well, okay, so we're calling this subroutine, which takes our code over to this side. So this code is going to execute top down. When it reaches line 17, it's going to come over here and go all the way down to the end sub. Then it's going to come back and pick up where it left off on the left side. Well, over on the right side, we have sub and we have display address info, and then you see the open and close parentheses there, meaning you don't have to pass anything to it. It declares 3 strings, line 1, 2, and 3, sets them and prints them, and then it ends. So it doesn't really do a whole lot. It's just printing out something to the screen. It comes back over here, finishes off, and then the program ends. So this is just a really simple example. This example is taken out of your book, but in the book, this is example 2-5, which is on page 60. And when you look at it in the book, they've got the flow chart there, and they've got the pseudocode there, but they didn't actually create real code for it. So that's what I did here. This program is out, and if you go out to Blackboard, and you go to Learning Units, under Chapter 2, and you go to Examples, this right here, this EX2-5, I'm just going to save it to the desktop and show it to you here. But this one is what I just showed you on the slide, right? So you've got 2 variables. You get your inputs, call this subroutine, and then you print out the answers. The subroutine is down here. Notice the subroutine comes after the sleep statement. So what happens is when the program runs, it starts up at the top. These are just all comments, so it doesn't mean anything to the program. Notice, though, on line 6, this is a different type of statement you haven't seen yet. It says declare sub display address info. In FreeBasic, you have to declare all of your modules at the top. And all you have to do, see if I scroll down, I have my subroutine sitting right down here. The header is this right here. I can copy that to the clipboard. I can come up to the top of the listing, and all I have to do is type in the word declare, and then put the header information right after the word declare. So you just, essentially you're duplicating the header up at the top, but then you just put the word declare in front of it. And you have to do that in Free Basic. Now most languages you don't have to do that, but in this language you do. So anytime you have a module, you have more than one module, you have to declare it. So if I were to come down here and create another module, right? Sub show welcome message. So I type in the word sub, I type in the name of my subroutine, the open and close parentheses are necessary, and then I print out, this is the body of the modules, printing out a message here, and then end sub finishes the subroutine. All three of those lines are needed, and then what I'm going to do is take and copy this to the clipboard, and I'm going to come up to the top of my listing, and I'm going to stick him at the top, and I'm going to put the word declare in front of it like that. So now I've got two modules, and this guy is ready to go. I can call him anytime I want. So in my program then, I can just say call show welcome message. So when this program runs, it's going to start by declaring a couple of subroutines. That doesn't do anything as far as the program. It doesn't show anything or make anything appear or disappear. Creating variables doesn't do anything either. It's all internal stuff. But when it gets to line 13 and it calls show welcome message, that is going to take you down to here. It's going to print out welcome to the screen. When it hits end sub, it's going to come back up to line 14 and continue to do these inputs. Get the customer name, get the balance. Then, when you hit line 20, it's going to call display address info, and that's going to take you down here. It's going to run all of this code until it reaches the end sub. Then it's going to come back up to here, these things here. Now when it hits sleep, it will pause, wait for you to push a key, and when you do, it will finish or terminate the program. And so, the whole thing, it's really hard to see the whole thing at once. You can read that no problem, right? That's even better yet. Anyway, that's the deal with creating these modules. So that kind of makes sense, but how do you actually know when you need to create these things? I mean, you're showing me things that you're doing, and it makes sense. But how would I know when to create one of these puppies? And that's something we need to talk about, and we'll get into that. We're going to take a break here in a few minutes. But just before we do that, as far as naming a module goes, just like with variables, you can't put spaces in a module name or start with a number or symbol. So when I create, my my procedure here, I can't put a space in there. It has to be one block of text. And you can't start it with a symbol or a number. Outside of that, pretty much anything's fair game. Again, choose a name that has meaning, right? You want to call your procedure something that makes sense, and it's usually 2 or more words, and it's like, as I said, print, report, show information, something like that, right? And then once you name it, you follow it with a set of parentheses. And for now, for what we're doing, we're not putting anything inside of them. So it's just open and close parentheses, and you're good for the subroutines we're building to start with. And then it says using Pascal case when you're naming them. That just means to capitalize every word as they come along. Well, That's probably good enough for now. Why don't we take a like a 10-minute break, and we'll get these slides done after the break, and then you have some extra time if you want to head back over to the other room. So we'll take about 10 minutes.
Examples to show us. Just gonna ask a second ago, but
Oh, sure.
you just wrote no where you were.
Okay.
You just wrote print ABC manufacturing.
Oh, right here.
You have to do line 1. No, not there.
Oh, okay.
Up.
Oh, up here.
It says line 1 equals this, and then you wrote print line 1.
Oh, I see what you're saying. Could I have just
wrote print ABC manufacturing?
Yeah.
Okay.
Yeah, they.
If it's a little more complex.
Yeah, they went through all the trouble to create these variables. It wasn't really necessary for them to. Yeah. Yeah. It would. Yeah, I would have just printed them out directly myself too. It's easier. So sometimes these books they just do dumb things. So they're trying to show concepts, but they don't always write the best programs, you know.
I was trying to find where the free basic alpha is.
Oh, okay.
I've got a different version of it.
Yeah. Okay.
After you edit.
Yeah. Do you like it?
Yeah, it's all right, but it doesn't have your column.
Oh, okay.
So when I try to run it, for
Doesn't
the
like
example that you had up there,
Yeah.
it says only valid and lang depreciated or FB like.
So you don't put call in, it works.
But I imagine you gotta put something there.
Yeah. You can just try that.
Yeah. I like it. Yeah, besides running into a couple little things that are different between that one and this one, but.
Split screen, it's more of a
Yeah, you get.
environment.
Yeah, I like, you can get all kinds of stuff. I've got 2 things up here right now. And you were saying how things kind of look cryptic or whatever, and some of it.
Yeah, briefly.
That's my preference. You give it a variable, you label it a variable.
Right.
And if there's any time in
What's
the
that?
future when you
Yeah,
go
that's
for a
what I
10-page
had the
document or
homework done
something
the
like
next
that,
day.
you can always go back to your
Actually, I was right now, but it's all this stuff.
I guess it's like, some people like tomatoes, some people like
Yeah.
tomato. But would you mark that wrong if I say?
Just go home and get it
No,
done.
You were saying up there, there's a lot.
Well, yeah. I mean, but like you say, there's different.
Some people, yeah, as long as it's, I know that a lot of people, they write thousands of lines of code and never write any notes, so when somebody's looking at it, like,
Yeah.
what is this? I can't do it. Job
Document.
security.
Yeah.
The guy who wrote it.
That's true.
Fire the guy who decided.
Yeah.
To get it. But
Yeah. Right. Okay. Well, that's
line is done.
yeah. That's. the way, there's a restroom in the library if you ever. It's just one on either side of the doors.
Can you show us more about Visio?
Yes. Yep. We'll definitely do that. Make sure it's on here. It should be. Yeah, it's yours. Yeah, we're almost through these slides. When we get through the slides, I'll work a few programs with you in here and show you Visio. And after we're done in here, I'll just head over to the other room, the ATC. If anybody wants to go over there and print anything out or work at all. So, or if you just love the class so much and you can't bear to leave, we'll open up the other room too. So it's. And next week, of course, we'll just meet over there like normal. So. So we're going to talk about when to create these modules, and we'll start on that here next. So when to create modules is, we talked about the modules, and you've seen kind of the process here. The question now is, okay, how do I know when to create a module? Makes sense, but when do I do this? And it's something you sort of learn by experience, but basically when you have a bunch of statements that all fit together to accomplish something, maybe you've got 5 or 6 lines of code that all work together to calculate something, or whatever, that's usually a good candidate to put it into a module. So that's usually when I recommend that people do that. Of course, the tighter, like if you have a block of code in a module and it does 2 or 3 things, that's okay, but it's better if it just does one thing. And they call that functional cohesion. The idea is that if the function or the procedure just does one thing, that's always better than if it does 2 or 3 things. If you break your program up into many modules, that's usually not a bad thing to do. So it's generally a better way to approach it. The more you break things apart, usually the better off you are when you write code. So. And as we go through the course and we start doing more complicated programs, you'll start to see how and when to do modules. It'll start to make more sense to you as you go. What we're doing early on here is we're just doing some pretty simple ones, and it'll start making more sense. But with variables and constants within modules, this is one of the things that you have to realize. Anytime you create a variable inside of a module, it's only usable inside the module, and it can't be used from anywhere else. So let me show you what I mean by that. I'm going to switch over here and put together another example. If I had a program which length as integer, width as integer. Now, by the way, you might run into this once in a while. You notice that the word width there stays in bold and length does not. that's usually a bad sign. What that means is that you're using a variable name that's a reserved word. In other words, free basic, when it sees width, it's like the name of a command or something, and it has issues with it. So usually when you see it in bold like that, what you really want to do here is change the name to something different. And say I'm doing length and width of a lat. I could something like that, and it would take care of it. Well, another example, if you use the word print, not a very good choice because print is a command. So just something to keep an eye out for. If you ever see your variable in dark print like that, you need to change it, name it something different. So I've got lat length and lat width. Now, let's just say I want to call a procedure to get that information. So I've got to call get lat dimensions. And I know that thing is going to go out and ask the user for the length and width. So that's cool. It's going to do that. And then maybe I've got another procedure here to print. Let's see. Dimensions. Calculate area of lat. And another one to display results. So my main program is just going to have 3 calls out to 3 different procedures. And that's it. That's all it's going to do.
All those different modules can use the same variable.
Yes. Right, that's what I'm going to show you next. Yeah. So we have a procedure, or a program here that calls 3 separate procedures, and of course they're not implemented yet, right? So they're just sitting here. Now, sleep, of course, the program ends when it sees the sleep, and underneath that, I'm going to implement my procedures. So I'm going to have sub get lat dimensions, and it's going to input what is the length of the lat and what is the width of the lat. That's all it's going to do. Now, if I were to try to run this program as it is right now, it's not going to work because I don't have these other 2 procedures implemented, nor do I have any declare statements up there. So I want to make sure I get everything in place before I try to run it. So I'm going to put in my comments, and then I'm going to declare. Now, actually, just to make life easier, I'm going to take these 3 lines of code, copy them to the clipboard, and paste them up here. And then I'm just going to put declare sub. Whoops. Declare sub, and I'll do that for each of these. So copy this. Right, so I got that. So I've declared my subroutines at the top, so we're good on that. And if you want to put a comment in there, you don't have to do this, but just kind of separates things out. Declare my procedures. I'm declaring my variables. And then I'm calling my procedures here. And then the program's ending. So for get lat dimensions, I've got my 2 inputs. Now, if I try to run this program, it's going to give me errors. And the errors that I'm getting are showing up on lines 20 and 21. And the problem it has is it doesn't know about these variables. Now, So how does it not know about them? They're sitting right up here. I declared them up here. I just want to use them in my procedure down here. Well, the problem is that when you think of a procedure, the idea is that it's self-contained, that it doesn't know about anything else around it, and it's independent. Well, that's fine, but we're using these variables, and they're up here. Our module's sitting down here. Now, what if I were to say, look, then let's declare these things down in the module. Will the program run? It still doesn't like me. Sometimes these errors are kind of cryptic sounding, but it looks like it's just not happy with anything here. Lot length and lot width.
Where'd you see that it said
line 20? It's got this really cryptic error message here and here.
No, I mean, why did you think? But it says calculate area of lot.
Yeah, it's
bad.
having problems with your other.
I think it's having
Oh yeah, that's what the problem is. You're right. Yep. Okay. I was wondering why is it failing. I'll just comment them out then. Yeah, that's right. That's the issue. So I'll just comment them out for now, and so it seems to be happy. At least it runs. So, okay. Yeah, that's true. So let's go and do the next one. So calculate area of lot, and that one will be sub calculate area of lot, and we want a variable named say lot area. We'll do this as an integer. You have to make that call when you create a variable. Do you want to make it a single or an integer?
Should you have had to make lines 20 and 21 then, or they probably don't need to be there?
It's going to need them. Yeah. Well, that's a good. Yeah, I mean that's the question. How do I get the length and width down into here? And we're running into troubles. Is the bottom line. What we really need to do is go back up to the top and add the word shared into our declaration. Because really what we're after here, we want to share these variables with all of the modules in our program. And so by saying dim shared, that accomplishes that. So if I do it that way, I don't need to create this anymore. In the get lot dimensions procedure, it'll know about these two variables because they were declared as shared variables up here. So when you see the word shared, it basically just means they all have access to the variables. And sometimes we call these global variables. They're globally available everywhere. So that takes care of that issue. And now if I say lot area, I can say lot area equals lot length times lot width. So I need another procedure to call, let's see, it was display results. So I'm going to come down and do a display results. I'm going to say print lot area is lot area. And
Why isn't that sub bold?
why is what bold? The
31. It's not bold like the rest of
the sub. Okay, that is a bug in FBIDE. If you hit enter, it'll bold it. Sometimes that happens on the last line, and there's nothing really wrong there. But that's a good catch. Yeah, if you just hit enter, it'll usually fix it. If it doesn't, then there is something wrong. But yeah. So if I go, what's that?
Line 14.
Oh, yes, good point. Maybe I should have brought caffeine in here. Caffeine and sugar, and this is not enough of either one. Anyway, Let's see. Okay, so lot length, lot width. Yeah, let's see what we get. 90 by 240. Lot area is 0. Well, that doesn't look right. So what's going on? The two variables that I declared up top were lot length and lot width. There's no lot area up here. The problem is that when it gets to this point in display results and it sees lot area, it says, you know what, I don't know what that is. To me, that variable doesn't exist because, well, you say, why not? I declared it, but I declared it inside of this procedure. So this procedure owns this variable. Its lot area belongs to this procedure. So if he wants to use his variable, can't do it. So what happens in free basic is it says, look, I don't know what this is, so I'm going to create it and set it to 0. Now if I had put an option explicit up at the top, that means I can't use variables unless I declare them. Then I get a compile error, and it says, look, you can't print out a lot area because you haven't declared that variable. Well, so yeah, yes I did. I declared it right here. It says, well, yeah, but that's up in that module. We're down in this module. You're trying to use a variable in this module, but you declared it up in this one. That's the issue. See, you can't share these variables unless you go to the top and put it up top. And then, of course, if you do that, you have to say dim shared lot area as share like that. Now, if you do it this way, you've got 3 shared variables, length, width, and area. So I won't have to declare it here in the calculate area of lot module. And everything should be fine. It's sharing these variables now. Let's see if we get this to work. So I've got 90 by 240 lots. I've got 21,600 square feet. So it looks decent. And, but that's the thing, you have to make sure all the variables are shared if you're going to pass them around to the different modules. So, well, this whole program is kind of silly. All it does is multiply 2 numbers together to make it a little bit more interesting. We could take into account, and this would be an estimate, that the house and driveway maybe would take up 40% of the lot area. I could say calculate adjusted area of lot. Now if I change the name of the module, I have to make sure I change it up here in the declare statement. And when I call it, I have to change it there as well. So anytime you rename something, you have to be careful that you propagate that change all across everywhere. Because if you don't, it'll nail you on the compile. And so calculate adjusted area of lots. It's going to only give me 60% of the lot. So the other 40% we're assuming is house and driveway. Now, of course, if you wanted to really be exact, you could ask them for the length and width of the house and the length and width of the driveway. And you could calculate those areas and subtract them out. But that's just a little more fun than we want to have right now. So this is just an estimate. But so if I run it and I go 90 by 240, I'm down to 12,960. So, right, so if you're trying to fertilize your yard, you need to know how many square feet your yard is. You could write a program. Now, let's say that you were, okay, this is a corny example, but you were selling fertilizer, and somebody comes in and says, well, this is the area of my yard, and it's the dimensions of my house and driveway. Of course, if they know all that, they could probably figure it out themselves, but you could calculate it precisely and say, okay, this is how many square feet of fertilizer. Now, okay, it's not going to take into account trees and all the other things, but it'll get you closer. Or you could just take an estimate and say, well, I'm going to just take out 40% of what you told me and assume that's your house. But you know, anyway, just as an example, you could do something like that. It would work out fine. So, when you create a program, declare your modules at the top. Make sure they agree in the names with the implementations below. When you declare your variables, declare them as shared variables. And then you call your procedures with the call statement. That call statement, by the way, is optional. And so you don't have to say call. If you prefer to just go like that, that's fine too. Some people like to use call because it kind of stands out then, like, okay, I'm calling another procedure. And some versions of Free Basic don't let you use call, so you have to just go like that. But in this version, you can do it either way. Now, when you see the word sleep, you think, look, well, sleep just means wait for a key to push, right? What happens in case it's going to call this, this, and this, and then go to sleep. When I push a key, it wakes back up, and then there's more code to run below it. When Free Basic sees a sub, it skips over it. Doesn't actually go into the subroutine, and just goes to the end of the listing. So bottom line, after the sleep is where you would put all your procedures, and then top is where you declare them. And if you do that, you're all set. It should be fine. So, any questions on that at all? Makes sense to you? So this slide right here, global variables and constants, is what we're talking about with the shared that I just showed you in that example. That's what this slide is really saying here. And then, okay, I want to talk a little bit about Visio here in a few minutes, but just to get these slides off the table here. The chapter wraps up with a section on good program design. And these are just some tips that they talk about to make a program well designed, well written. And the first thing they talk about is using comments. And we've talked about this a little bit before, but comments help you understand what's going on in the code. You place them where code is not obvious. Right? So basically what we're doing here is we're saying, look, if you're down here, for example, right here, you have a calculation, right? It's lot area equals length times width times 0.6. Now, if I didn't have the 0.6 there, it would probably be fine as it stood. I mean, it's pretty obvious that the area equals length times the width. But they're looking at that, they're saying, well, why is the 0.6 there? Anyway, what's up with that? See, this would be a good place to add a comment where you'd say, okay, you know, we're taking 40% of the area away for house and driveway. Right? So you put a comment in there like that, and it just helps to explain, well, why did you multiply this by 0.6? That's really all we're saying, is that comments, when they're used, you don't have to put them everywhere, and if it's obvious, there's no sense in doing it. So like for example here, to put a comment here that says, ask user for length of lot. Well, thanks for that, but we can kind of see that pretty clearly on the next line. So for a comment like that, not really necessary to do, and in fact, all it really does is clutter up the code, and it's just not needed. So the point is just put comments in sparingly whenever you need to use them. Most programmers don't like to comment their code anyway, and so putting comments just where they're needed kind of makes sense. So, you can add comments to flowcharts also. Let's take a look at that for a minute. In fact, on the next slide, I've got an example of this, and this was done in Visio, and I'll show you how I built it here in a second. But this right here is called an annotation, and this is how you can add comments to a flowchart. Let's pop up Visio and I'll show you how I did it. So I'm going to go to All Programs, Microsoft Office, and Visio here. And a little bit of review here with Visio. When Visio comes up, you're interested in building a flowchart. So on the left side, you have all the template categories. You want to choose flowchart, and for us, a basic flowchart is fine. And I can just double click that, and it will build one for me. And this is the page, and so if you want this to be larger, you can just go up to the drop down, and if I choose width, it will make it a little larger, and you can scale it, zoom in even more if you'd like, or zoom out. So on the left, if I was going to do a flowchart, I would want to start with a lozenge. Now in Visio they call it a terminator. It actually can be used to start or terminate a flowchart. So I basically just drag it onto the sheet, and then I can double click on it and enter my text into it. So there's my start. And now, usually, well, if you look at the book's examples, when they do flowcharts, and it comes time to declare the variables, they will put in here a box for that, like this. So you drag the process box in, and you notice how I'm lining it up. You see how the little crosshairs turn black to indicate an alignment. It's lined up here, and if I double click in the box, I can say declarations. And notice how it centers everything. Now, if you look in the book, like on page 60, it shows declarations top aligned. And what I can do here is, remember how I did this now, with the top alignment. Format text. Easier way I did it. Click. This will get me.
No. That drop down arrow right underneath there. Oh, the tab that you were just at.
Oh.
Go right. Keep going all the way in.
Oh, this here? Yeah. Like. Well, maybe I'm just trying to think what I think. Maybe then let's just. I left aligned it at least. Let it go down. Maybe that's all I did. It still centers it in the box vertically, but I just went from a center alignment to a left. And then, in order to achieve the indent there, I just hit the space character. I couldn't figure out how to tab it, so I just hit space. Dim age as integer. Now, the box isn't big enough, so I can take it, click on its edge, and you need to see the left-right arrows. I need to hover right over top of a green dot, and I can just make it wider. Double-click back inside of it, and then I can dim rate as single. So, and then I could take this box and I could make the thing smaller in terms of its height. Something like that. And that will get me close to what the book shows. Play with it a little bit until you're happy with it. And I'm not real picky about the way you do these. It's not like they have to be perfect. But something like that would work. And then if I wanted to do an annotation to this thing, there's a symbol over on the right. It's at the bottom, right down here. It says annotation. And if I click it and drag it over, you need to line up the line with one of the dots. And in this case, it makes sense to put it here. I could also stick it, let's see, it doesn't want me to put it in the corner. It just wants to go in the centers, or right in the very middle. So I'll stick it on the end over here. And then basically you just double click in the annotation box and you can say the rate. You just make a comment, you know, the rate is subject to change. You can move this. Now, usually the purpose of it, annotations might be to describe what the variables do, or if you just wanted to add some comments anywhere in your flowchart to make it more understandable, you could do these. Of course, annotations take up room, and they're usually not used a whole lot, to be honest. But that's how you would do one if you wanted to do it. Now, then I would go in, you know, and I would start to ask for inputs. So here would be the input symbol. And input, what is your age? And again here, if you don't like the size of the symbol, you can change it pretty easily. Line it back up again. And to connect the symbols together, you go up to the connector tool up at the top and click on that, and then just move your mouse until it hits one of the red dots. Hold the mouse down and drag it to another endpoint. Now see, these don't line up. And so I could go back to the pointer tool, click this guy, and just move him over to the left. And of course, when I do that, now he doesn't line up. So play with it a little bit and you can get it to line up. But so that's the basic idea. And then, you know, this lozenge, if you want to make it smaller, do that. You can play around with it.
You know, if you click the light blue ones, you can not have to put the arrows in. Like if you click like data on the side.
Oh, okay.
Click data. Just click it once, then click down on your and hit that light blue arrow.
Oh, I see.
Just
this
click
blue
the
arrow
blue
here.
Arrow. Then
Yes.
it'll draw your box and put the connector arrow in.
Yep. Yeah, I never knew I could do that. That's pretty cool. Yeah. I definitely like that. That's what those are for. Cool. Yeah,
If
good.
you click again, it will add another
one just like it.
unless you click on the left side there.
Nice. That's great. Good. Okay. Yeah, that's awesome. So that makes things a little easier. So yeah, and then, you know, so we did the annotation. If you want to colorize these, you can click the fill tool and fill these with a little blue color, or, you know, I just did the border of the chart. I'm going to hit Control Z to undo. I want the paint can to fill the thing. And so obviously you don't have to colorize. I mean, if you really want to get fancy and play around, you can, but it's not really necessary. What I did here was I just colorized this. I colorized it because I wanted to show you these circles here. If your flowchart gets too long to fit in a column, and you want to make multiple columns, it's fine. You just draw a connector symbol. So I would take this circle right here. Usually you put a letter in it, like A, B, C. And draw another one up here, name it A, and then go about. That is cool. Yeah, I know. He gets excited about stuff like that. What can I say? All right. So that's just a connector. If you need more space and you want to put them in multiple columns, you can do that too. So that's all of that, just to show you this whole deal with the comment. Anyway, if you're happy with this flowchart, by the way, and you want to create a Word document for your assignment, right? So if I pull up Microsoft Word and I wanted to run with this thing, say this is case problem 5 or something. Basically, all you have to do is highlight the region and hit Control C to copy to the clipboard. Switch over to Word and do Control V paste. If you don't like the keyboard, you can click up on Edit Copy and Edit Paste. But I just like to use the shortcuts on the keyboard because I don't like have to reach for the mouse constantly back and forth. It's just me, so. I don't know why it takes so long to do a paste. You wouldn't think it'd be a big deal, but you can thank Microsoft for that. It's their own software. I mean, come on, how hard can this be? But eventually it'll get there, and you can resize it. It's there, so.
So that's what you have to do to zip it to send to you?
Yeah, right. When you send me, right, your stuff, you would send me the document along with all the BAS files. So.
Sheet there?
Yeah. Yeah, you can. You have one Word document, just throw them all in there. Just label each one of them, you know, like case problem 5, and then have another one that says 6. And you know, that'd be fine. Does anyone in here use a Mac? Nobody. Oh, okay. Well, I've got a Mac at home, and I'm running Windows on it, but I'm trying to get used to Pages, which is their word processor, and it's tough to go back and forth between Pages and Office. Do you use? What do you use?
I don't have Windows.
Use the default stuff that they have. Okay. Yeah. Then the keyboards are different too, so it drives you crazy. Anyway. Yeah. So as far as creating your now the source code, to put the source code in here, you have a couple of options. If you want to. If you're familiar with the screen capture software, well, see, it's not going to work real well with a long listing. You're probably better just to take all your code. I can do Control-A to select the entire thing, then Control-C to copy it, head back over to Word and do a paste. Now when you paste it in, it likes to, it's not really double spacing, it's like 1.15 or something. It's annoying. Select my code, and I select this button right here, and I choose remove space after paragraph, and it tightens up everything into a single spaced listing. And if you want to change the font to a fixed font, you can do that too, which what a fixed font does is, I like Consolos, but you can use anything you want. It makes every character the same width, basically. And for programmers, we like things to line up. And when you do it that way, everything lines up nicely. So just a couple things you can do to, you don't have to do these things, but it makes the doc look a little nicer. And of course, spell check will go nuts on this because it wants sentences, right, with normal words.
So why would you switch something like this over to Word?
Just so that you can put it in one file that I can look at, so you can print it out. So
you do want us to switch
it doesn't really matter if anything printed. If you want to print out the flowcharts and the programs, you just staple them all together. That's fine too. I just need something printed form to grade it. So.
Blackboard isn't what gets graded?
Well, that's in addition to the printout. You also send it in Blackboard. So if I wanted to run it, let's say I looked at the document and something didn't seem right, then I could run your program. And
So once due tonight, you want them to copy too?
yeah. Well, we'll have some time. If you want to go back to the other room, we can print them out over there. So is that making sense? You had questions on any of that? Shockingly enough, they see my last name as a typo. Just can't believe they would do that. You can add it to dictionary, but then you wouldn't want to add these probably. This is just for Word. And anyway, put your name at the top, obviously, so you can print it. And I'm not really picky about format, as long as all the stuff's up there. It's not a complete disaster. My border. Anyway, whatever. Okay. Back to the slides. So that's an example of the annotation. Okay, we've talked about this already, but choosing identifiers wisely. When you name your variables and constants, choose names that make sense, or at least comment the variables so you know what they mean if you're looking at them, if you use abbreviations. Meaningful names, make code as self-documenting as possible. That basically means try to make your program readable. If your names of your variables are named well, it says area equals length times width. It's pretty much self-documenting. You wouldn't need to add a comment to that. If it said A equals L times W, as long as you, in your variable declarations, you put what those variables meant, that would be fine as well. Temporary variables to clarify long statements. This is something that they have an example of in the book, and it's on page 73. And what they're doing is they have an equation that they've got, and it's quite a long equation. And I'll just type it in here, just randomly throw it in. Salesperson commission equals square feet times price per foot plus lot premium times commission rate. Now, first of all, if you look in Free Basic, this gray line over here means that's the edge of an 8.5 by 11 inch page. So if it goes over the gray line and you go to try to print this out, it's going to run out of room, so you'll have to deal with that. Now, Free Basic doesn't have a print in its menu, which is kind of strange. It can't print out of its own editor. I don't know why, but anyway, it's just showing you, look, this is a really long line here. Well, so the question is, what do I do about this? In Free Basic, you can put what we call a line continuation character in your program. It's an underscore. And you can stick it at the end of the line and continue to the next line below it. And so that's one way you can get around a long line of code. But what they're saying is, look, this is a really long equation. Why don't you break it up a little bit? So they're saying, look, why don't you say base property price equals square feet times price per foot. Now if I do that, then I can take this piece here and replace it with base property price. And then this line isn't quite so long, although it's still long enough. So then they say, look, why don't you take the total sale price equals this. Move this up like here. Then I can take and replace this, and then I don't need the parentheses anymore. So now I've gone from one line of code, which is quite long, and I had to split it apart, to 3 lines of code. And yeah, I've got some more variables in here, but hey, at least it's a little bit more readable. The nice thing about having more variables is for testing. You can do these things in stages. Rather than one big long equation, you can break it apart so that you can make sure this is correct, and then this is correct, and then this is correct. And it really makes it easier for debugging. And we'll talk more about that down the road, but as I say, breaking things apart in a program is usually always a good thing to do, whether it's modules or even variables like this. Make things easier to test and debug. Put space in and around code to make it more readable. So you'll notice that I try to put space. I don't like to get too carried away, but like I put a space between things up at the top here, like when I declare my procedures, I put an extra space there and here, and after the sleep there and before it. So, and then notice, like, when you add two things together, I put a space in there. That's just a habit that I've gotten into. But you look and you notice that without the spaces in there, it's a little bit more difficult to see what the code is doing. You see that? The symbols jump out a little bit more clearly if you put the spaces in. It's little stuff like that, and it is little, but it just makes your code more readable. So I always like to just pad things a little bit with some space, and it just works nicely for readability. So that's all they're saying on that particular slide there. Put more space in and around code to make it more readable. And then finally, they're talking about writing prompts for the user, and they're saying when you ask the user something, it's nice if you tell them how to enter it. So in other words, if you're asking a question like, what is the quantity? If you have a range, let's say that you don't want to let them enter a quantity over 100. Sometimes it's helpful to give them a little note or comment in the prompt telling them what the range is. It just helps them out so you know what the valid range is. And remember, in BASIC, if you put a semicolon here like this on an input statement, it will add a question mark for you, so you don't have to put a question mark there. In fact, you shouldn't put one there if you have a semicolon. That's why I gotta get this thing back to what I had before. What is the length of the lot has a nice little question mark next to it and a space. And I don't have to do anything to get that other than put the semicolon there. If I had put a question mark in, then I get two question marks, and I definitely don't want that. Now, sometimes you don't want to ask a question. Like here, instead of saying what is the length of the lot, I might want to just say enter the length of the lot. So I'm not really asking a question here, and I would probably want to put a colon or something like that. Well, with the semicolon there, it's still going to put that question mark. So in that case, I would use a comma instead of a semicolon. And then what you'll see is it says enter the length of the lot with a colon without the question mark. This is very specific to BASIC, by the way. Most languages don't do this kind of stuff, but just in BASIC, so that you know, semicolon puts a question mark, comma does not. So it depends on what you're asking, how your framing the input prompt. So just a little thing, but I did put this in the slide here at the bottom. That's basically what we're saying on that. Questions on any of that? Visio, any questions on Visio? I think those were the basic things I wanted to talk about there. So that's it as far as the chapter and the slides go. I'll end this recording session here. And what I want to do next is just talk about your assignment. What do we got for time? Quarter to 8? Yeah. So I'll talk about your assignment for a few minutes, and then we'll be finished here. And then if for those of you who want to head over to the other room, I'll let us go on over there and want to work or have any questions. So for the next assignment, close this down. Got your 3 case problems here, and first case problem, let's move the font a little bigger here so you can see this. Is design a program to create a mailing address for a customer. I know these examples are very simple, but we're just trying to get the concepts through, and we'll make these programs that get a little more interesting as we go. You're like, wow, it creates a mailing address. Isn't that neat? Yeah, well, they'll get a little more interesting as we go. This one, though, is basically the idea is it's going to ask you, the user, for first name, last name, address, city, state, zip. So all those things it's going to ask for. And then it's going to put all of those things together to create a mailing address and print it to the screen. Now, in FreeBasic, when you want to connect strings together, let's pop up another window here. I had a first name and a last name. I did an input statement. What is your first name and what is your last name? Right? And I wanted to connect the two together. If I say print first name, semicolon, last name, we'll put the two together. Not true. What did it do? Oh, I have two first names. Did that on purpose, of course, to show you that you should always, that you should never do that. Okay, so, but it doesn't put a space between the two, so it just kind of crams them together. So you're going to want to do something like this. So you've got your first name, and then you throw in a space, and then you throw in your last name. So you got that space in there, and then it should be okay. So when you're building this mailing address, you're going to have to do that for their name, and then as far as the city, state, and zip go, if you have city, you're going to need a comma and a space, right? And then state, space, and then the zip. So if you do something like that, you can throw in the commas and spaces and all that, and just print up all these things side by side, and that'll give you the lines of text that you have to print out. And so that's how you can do that kind of stuff in just a semicolon between your variables. So that's what the program's going to do. Now, in order to implement it, you're going to create variables for all the data. So you're going to make a first name, a last name, and all these other things. And when you create these things, create them as shared variables. And then you're going to create two modules. One is called get user information. One is called print mailing address. And your main program is just going to call the two modules, one right after the other. And first module will ask the user for all this stuff. And the second module is just going to print it out. So you're just dividing up your code into modules, basically, so that you segment them up a little bit. So that's the first one. Oh, did I talk about making, it's one thing I didn't get into in Visio here. You're doing a function call, or a call to a procedure in Visio. Let me show you that here a second. Let's say that you want to make a call to a module. The symbol that you would use is this predefined process box. Now in the book, for some strange reason, their symbol has the line going across the top. You can see it on page 858. And I don't know where that came from, because no one uses that type of symbol, at least that I know of. usually you put the lines are on the sides like you see in Visio there. So when you see that symbol in the book with the line across the top, in the real world, whatever, we'd use them on the sides. And I would say call get user info or whatever it is you're calling, and then parentheses on the end of the name just as you see them. Tighten this up a little bit, and that's the idea. So then maybe I would do some processing that, and now that you told me that trick, and I've done it this way. This guy, wow, look at that. That's like magic, right? You might do some processing, whatever it is, and closing out. And so you're calling the module. Now to implement the module, you're going to have another terminator here somewhere. It will say get user info, like that. And then inside of that module, you're probably going to be doing some I/O, so input get name, and whatever else, get age, that kind of stuff. And then the thing is finished, you're going to put another lozenge out here. And what you put here is varies. In the book they put return, so I guess that's what I'll put. Return like that, and that would work. Okay, so the program starts right where it says start. So there should only be one start and end on a flowchart. That's where it goes to run to begin. And so it starts here. It calls this module, which is over here. It does all these things, and then return takes you back here for the next thing, whatever the processing would be when you finish. So that's essentially how you would do that in Visio, how you would diagram that out. So when it asks you to do the flowcharts, and if you have more than one procedure, then you just make as many of these as you need to on the right, and just throw them on the page. And as far as that goes, the page, you've got a fair amount of space. You should be able to fit most everything, especially these early assignments, on a single page. But if you needed more, you could use that connecting symbol to move around, to go to different pages or whatever. By the way, for future use, if you ever want to do an off-page reference, there's on-page hooks you from one point to another point. An off-page reference takes you to another page, and it looks like it wants to add it for me. That's nice of it. So it's Microsoft Mind Readers there. It hooks you to another page. So that's something that you probably won't really need to worry about. If your flowcharts go over a page, that they're pretty large, but that's what that's for, in case you're curious. So that's the first case problem, which is case problem 4. Submit, you're going to want to give me the VAS file, which is the program, and the VSD file, which is the flowchart. Both of those you can name CP4. So those are 2 files. There's 2 files for each case problem for a total of 6. And then your Word document would be the 7th file. And you would zip them all into a into a zip file and submit them. And then you'd print out the document so that I could grade it on the printed copy. And that's just explaining that a little bit there. Case problem 5. On this one, this is the gown one. This one I've got to check on because it looks like we had a gown size of 18,000, which doesn't seem right. The student enters their height and weight, and you convert the height into centimeters, and the weight is entered in pounds, and you convert it into grams. And then the gown size is 1/3 of the weight plus the height. No idea where that came from, but sure, whatever. I just like small, medium, and large, but that's fine. And then you output the gown size to the user. So that's what the program is supposed to do. On the implementation of this, create a module to get the student's height and convert it to centimeters. Do a module to get the weight, convert it to grams. Do a module to calculate the gown size. So you got 3 modules. The main program is just going to call the modules. It's going to call all 3 of them in sequence. Each one will do its job, and you'll end up with that gown size. And the only module that's not here is printing out the final result. So the main program is going to call the first module to get the student's height. It's going to call the second one to get the weight. It's going to call the third one to calculate the gown size, and then it's going to print out the answer to the user. So make all of your variables shared. Essentially, you've got your weight and your height and your gown size, just 3 variables. And declare those, do the same process that you did before. And that's that one. So flowchart in program.
So the gown size should just be a number?
It should be a number, yeah. But you came up, what was the number you were getting? It was like really large. Yeah, I've got to go back and look at the formula to see if that's really what they wanted. So I'll play with it in the morning. If I need to make any changes, I'll make them and stick out an announcement. But that shouldn't be much of a change. I'm not sure. I just have to go look back at it. So, 6th one is writing a program that determines monthly sales tax report. In this one, you're going to ask the user for the total sales of the month. You're going to then calculate the sales tax for the state and for the county. The state sales tax is 4% and the county is 2%. And then you're going to print out to the user the amounts of the taxes and then the total. So if they enter $1,000, then you're going to put, okay, 40 for the state tax, 20 for the county, 60 for the total tax, and just display that to the user. So, oh yeah, this is the spot where I had a figure up here that didn't show up. And let me see if I can make it appear. Not there. I'll fix that too. I've got an example of what the output should look like. Just for some reason didn't want to show up, so I'll fix that and you'll see. But basically what it is, when the program starts, it'll say what is the total sales for the month. They'll type a number, hit enter, and then it'll come up and say, the state tax is this, the county tax is that, the total tax is that, and that's pretty much it. So, but I'll get that working, and that's basically that. So the logic for this one, you're going to create a module called Get Monthly Sales that will ask the user how much they sold in a month. We'll create a module called Calculate Taxes. That will calculate the state, county, and total tax. The total tax is just the sum of these other 2. And then Display Report will present all the information back to the user. So in this case, you're going to have variables. You're going to have a county tax, a state tax, total tax to show, and then a monthly sales amount. So you create those 4 variables and then pass them all around with the modules and get them to work. Oh, this one too. There's, on this one, since you're displaying monetary information, Free Basic, when you go to display numbers, it doesn't really like to just give you 2 decimal places. So, for example, if I put total as single, I input what is the total, and I do tax as single. Tax is total times 0.06, and then I print out tax is tax, like that. Well, it just happened to work out, isn't that nice? Okay. Now it's just going to torture me. All right. Say it was a third. I'm not very good at math. It would print 3333, right? So, the question is, how do you prevent that from happening? Well, what if I just do 100? The tax is 6. It might be nice to show $6.00, right? Here's how you do it. First of all, you need to put the $sign into the string. So it's going to show the $sign there. But the real trick on this is you have to do a couple things. Near the top of your module, it needs to be, before you write any code, you need to type that thing in, and it includes a library which has some functions in it that you can use. So in English, that just means type it in, it'll work. Now in here then, I would say format, sure this is right. You would put format, and then in parentheses you'd put the variable that you want to show, and then in quotes 0.00. And what this means is that it must print out 2 digits to the right of the decimal, whether it needs to or not. So if the sales tax was $6, it would be forced to put 6.00. And if it was, 6.3333 repeating, it would go 6.33. If it was 7.778, it would round it up. So that's in the assignment. I'll switch back to this, but this is where it shows how to do that right in here. Here's how you actually would code it in. So for that last case problem, and any other points where you want to show currency stuff, that's a nice way to go in this language. Just do something like that. So 3 case problems. This is due June 3rd, and the first assignment's due tonight. And so what we'll do now, it's a little after 8. I'll just go over to the ATC, open up the room, and if you guys want to do anything there, that's fine. If not, that's fine too. So, cool. All right. If I don't see you over there, well, we'll see you next week. Oh, you got it. Great. Did you get my email?
I did, it's probably there, but I haven't.
Oh, okay. Yeah, that's fine. Well, you can, yeah, it's no big deal. I did.
Okay.
I did. I tried. It's what?
I probably won't get the.
What was your email again?
It was just, I have the, I have the
original Blackboard.
It will work though?
It will work.
Okay,
You just
when's
have
that supposed to be?
like fall semester. So it'll roll out. It's up to you. I know. It's just kind of temporary, but yeah, sure.
Probably too late for this now, but you're not doing attendance this week.
I forgot to take attendance.
It's all right. It's not necessary, is it?
No, no.
Okay.
Everybody's here?
Everybody's,
Yeah.
if you're not here, tell me.
The line you said include the VB compat, just put that at the top of the,
Yeah.
just like that, doesn't really matter.
No, just at the top before you write any code. Just put it up there.
Just for this
Was that Visual Basic or something?
Yeah, it's a Visual Basic
Compatibility?
compatibility library. Yeah. So they implemented
What's
it
the
in
dot by?
a binary.
Binary?
Yeah. So it ships with FreeBasic, and it's just something you have to include. I don't know why it's probably some type of copyright issue. I don't know what issue is there, but you just have to explicitly include it to get all the functions in there. So
Okay.
yeah.
But we haven't did it for any other one, so just for this.
Oh yeah, just for
But
this.
why? That's why I want to know why, just so I can understand it a little more.
Just if the reason it's
Oh, so when we did all the taxes and stuff until they rounded up, it wouldn't have did that if you didn't have. If you didn't have
right, it wouldn't print it out like dot.
Oh, okay. I can see. I get it now. Okay.
Yeah,
All right.
that's all. So
Hold on. I think I had a question on the centimeters, like the graduation thing.
on the gown size thing.
Yeah, it's kind of confusing. I had
Oh,
started
okay.
early. I actually had already read went in, but I kind of got confused with the sharing and all that. Like,
Oh, okay.
Like the sub when you declare when you started, like I'm kind of a little confused with that. So
Oh, okay.
I started it, but I actually forgot my USB. I
Oh,
came,
okay.
I don't know if it came a little late because I was working.
Oh yeah.
Just got a new job. So
Yeah, I remember you saying that. You're
Yeah.
trying to come up to speed on that.
Yeah, exactly.
Yeah. Okay.
Oh,
Well, basically, right, when you create your variables, you just put shared in front of them, like that. Like what W keeps
yeah.
doing.
Yeah.
God, it drives me nuts. Shared.
Because you do it so fast.
Yeah,
Probably
I
just
guess
like,
so.
You just automatic.
Yeah, like that. And then when you do a subroutine,
Yeah, automatic.
it'll automatically
Shift it
use
over
them.
and all that. So once
Yeah.
you go down.
Oh, tabbing? It doesn't do that in this. You
No,
have to
I'm
hit
talking
tab.
about it automatic. Oh, so you got to go over there yourself.
Yeah. You just push the tab key to push things over. So.
It's pretty much that simple. Then, so,
Yeah.
and so when I do that, then I call them.
Yes.
Before I start to build the molecule.
Right.
I gotta call them first.
Yep.
Just back to back. I don't have to.
Right.
And it'll still run straight. Okay.
Yep. Back to back. Yep. That's all you have to do. There, so.
All right, sir. Appreciate it.
Yeah. Yeah. No
So
problem.
let's do on the third.
Third. Yeah. Yep. So.
That classroom over there already opened up, or?
I'm not sure. They usually it probably is, but I'll